Hello students. Now I want to discuss with you one important topic from electrochemistry. So that related problems also we will discuss. Now the topic is electrolyte concentration cells. Electrolyte concentration cells. So generally in this process electrolyte concentration cells, in this electrolytic concentration cells we will discuss about one condition is for electrode, another one is the electrolyte. So the first thing is electrode. Another one is electrolyte. Here the electrode activities are same. Electrode activities are same. Here in this process the electrolyte activities are different. Activities are different. Okay, such kind of cells are called only electrolyte concentration cells. These are called electrolyte concentration cells only. So now generally we will discuss one example. Okay, one example is platinum is one electrode. Now hydrogen gas is present in that one cell, half cell. That one contains H plus ion concentration, that is denoted with C1. Next, here the double vertical lines represents here salt bridge. Next, another cell, that one has C2 concentration, H plus ion converted into hydrogen. It is also present in platinum electrode. Now platinum electrodes are the inert electrodes. Okay, those are inert electrodes only. Now next step in this reaction at anode, what happens? Reaction at cathode we will discuss now. Now here first one, reaction at anode. So in this process the hydrogen, it dissociates to form 2 moles of H plus ions and it loses 2 electrons. It loses 2 electrons only. Now the concentration of H plus here we are representing with C1. That is representing with C1 only. Next, another one here, reaction at cathode. So reaction at cathode, here also what happens? The 2 moles of H plus ion, the C2 concentration of H plus ions. Now this one gain 2 electrons, it convert into hydrogen. Okay, this is the process. So in this process we can easily write reduction. One is reaction at anode, means always it is oxidation process. This process is oxidation process. Now if you observe in this case, reaction at cathode, this is always a reduction process. This process is a reduction process. So what is the main we have to calculate the cell EMF of the cell only. According to the Nernst equation we can write, according to Nernst equation, so by using that we can write here E cell is equal to, that is EMF, E cell is equal to E naught cell minus 0.0 591 by n log of activity of H plus ion concentration. We can write H plus ion concentration power 2 at a right hand side. So which one is the right hand side? This H plus ion concentration, right hand side. So we can write here RHS by activity of H plus power 2 at LHS. So these are the concentrations of the H hydrogen only, right? By using this, what we can finally write in this case, the E0 cell of hydrogen at anode and cathode, both sides it is a 0 only we can take. So E0 cell value we can write it is 0. It is 0 only. Then what we can write finally, E cell is equal to 0.0591 by n log of. So what I am going to write here, in the above case H plus ion concentration or activity of H plus ion is right hand side is there, that concentration is C1. The next activity of H plus ion, that one present on the left side, that is C2. So here a negative charge is there, now I am taking here a negative. So finally we can write here C1 by C2. Okay, then afterwards what we can write here, E cell is equal to finally positive 0.0591 by n only log of C2 by C1. C2 by C1 we can write like this. So by using this process, so finally what is the conclusion? If C2 is greater than the C1, so if a C2 concentration is dominating more than the C1 concentration, then E cell is positive. If E cell is positive means, what about the delta G case here? The delta G is negative. If delta G is negative means finally we can conclude the reaction is spontaneous. The reaction is spontaneous reaction. Then next we will discuss that related one more problem that is also very very important in this problem. Next, so two electrodes are given here. A negative sign represents this one is in electrochemical cells, it acts like a anode. The positive sign of the electrode acts like a cathode. So in this process he introduced CH3COOH plus CH3CO1A. These are the buffer solutions. Buffer solution, that is which kind of acidic buffer solution. So if acidic buffer solution is introduced in a electrochemical cells, so how to solve that? E cell, what he is asking? E cell. Finally we have to calculate E cell of the given reaction. So now coming to the calculation of E cell part, according to which one? Acidic buffer solution. According to acidic buffer solution, generally we know that the formula is in Ka relations. Already we know that Ka relation also we can write. So H plus ion concentration is equal to Ka into concentration of acid by concentration of salt. N represents here normality relations only. Okay, normality relations. So here next further step is, here we have to calculate here concentration of two buffer solutions. One is present in the anode, another one is in the cathode side. So first we have to calculate for C1 case. C1 is equal to, here what is the meaning of C1 means, this one only, this is the C1, this one is C2. Okay, this one C1, the anode side is, it is a C1, cathode side is a C2. So the concentrations of that compounds given. Next here C1 is equal to, how to calculate that? C1 is nothing but here H plus ion concentration. C1 is nothing but, we can write Ka into acid concentration is X, salt concentration is Y. So we can write X by Y. Next, concentration of C2 is equal to, we can write Ka into Y by X. So C1 and C2, these two concentrations now substitute in the formula. So what is the formula? According to Nernst equation, we know that E cell is equal to 0.0591 by 1 log of, here product concentration means we can write here C2 condition alone, C2. So we can write here Ka into Y by X by Ka into C1 concentration, this one, Ka into X by Y only. So Ka both gets cancelled, Ka both gets cancelled. So next we can write here E cell is equal to 0.0591 log of Y by X whole square, Y by X whole square. Then if you substitute in this, you will get 2 into 0.0591 log of Y by X. So by using this, the finally E cell is equal to 0.1182 log of Y by X. So Y by X means here majorly we know that the concentrations of acids and salts only, we took already X is to Y ratios and Y is to X ratio. If you know the X and Y value, you will get E cell value of the given cell. This is the procedure for the calculation of E cell. In the next video we will discuss another different kind of methods. Okay, please follow my channel. Thank you.